A clock at the top of a mountain runs faster than time at the sea level. Why does this happen? This can be answered by two words: time dilation. But what is time dilation? It's the difference in times between clocks of observers in different frames of references. Time dilation is affected by two things: the force of gravity and velocity. So when the two observers' frames of references move at different speeds or are affected differently by gravity, time dilation occurs. Typically, time moves slower at faster speeds or in places with stronger gravitational fields. But why does velocity affect time dilation? Well, let's say you have a guy named Juan. Juan stands on this cart, which moves at a constant velocity v. On this cart there's a light clock, which is a mirror hanging directly above a light source. For every tick, a light beam shot up, reflected by the mirror, and returns back down. Now, let's add an observer standing on the ground observing the cart named Kim. Juan and Kim have previously synchronized their clocks. Now, the cart's going to move to the right x meters at this velocity, and both of them time how long it takes to do so. Juan's clock reads 5 seconds, but Kim's reads 6. How could that be? If you remember, Juan's standing on the moving cart while Kim is not. Relative to Juan, the car is not moving at all, but rather his surroundings move to the left. So when he watches the light clock, which is on the cart, the light moves only vertically, moving a total distance 2L. However, Kim sees the cart move to the right. Now, the light's moving both vertically, as it's still shot up, and horizontally, as the motion of the cart system affects the light's motion. As shown here, this will cause the light to move in a triangular path. If you use the Pythagorean theorem, the distance of the light to the mirror is this, making the total distance double that. As that's larger than 2L, it'll take more time to travel Kim's path than Juan's, and as the speed of light is constant, the time must take longer to make that distance. Because of this, Kim and Juan got different times, proving time dilation is real and that velocity affects it. One thing time dilation has helped us with is ensuring that astronauts on the International Space Station, or ISS, don't age differently than those on Earth, as time dilation is caused through the differently gravitational field. But how do they do that? As you see, the gravitational field becomes stronger the closer you get to the center of the Earth. The ISS, as it orbits the Earth, experiences 10% less gravity than those on Earth. Due to that, time would appear to run faster on the ISS. So how do they solve it? We can't change the gravitational field, so we turn to the other cause of time dilation, velocity. By increasing velocity of the space station compared to Earth, we can slow time. Between gravity and velocity, we can effectively cancel out time dilation due to the gravitational field. In fact, since velocity affects time dilation more than gravity, after 6 months, astronauts on the ISS actually age 0.007 seconds less than those on Earth. Time dilation affects our worlds in many ways, and understanding it helps us as we continue exploring space and depending on satellites to inform our world.